All right, so we come to section 2.3 about about visualizing variation in categorical variables. So this section in my desk, we now is moving to categorical variables. And for categorical variables, mainly in this course, we're going to use two way. One is using bar charts, and another one is pie graph to visualize. All right, so let's moving to the next slide. So first, talk about categorical variables. If we treat it similar to numerical variables, and bar chart is mainly is for the categorical one, and it's similar to histogram. It looks similar with it. The record data is category along the horizontal axis with the height corresponding to the frequency of the data. All right. So I don't think that we have like an example of a bar chart in the slide here, but I can make you something like this. So for example, if we have let's say I'm talking about the hair colors, hair color, hair color of the hourglass, right? And then the right hand side of the column going to be frequency emits. So in our class we have, like, let's say black color, let's say yellow, right? And maybe it's maybe gray. Okay. So so let's say we have like about 10 black hair colors in our class, and maybe 5 yellows, and could be like 15 gray color, something like that, right? So when we draw the bar chart, we can have like horizontals is for the hair color, hair colors. So that means we're gonna have like one is for black. Okay, so and then another one I can separate it with a gap. We don't need to make it like stick together, so to make it easier to see. And the other is gonna be yellow, and the last one gonna be like gray, right? All right, so I split these three 20 and 10 here, so then 5 is here, see that, right? So the black having 10, so I'm gonna draw is up to here. All right, the yellows will be 5, so up to here, and then the grays is 15, so let's say up to here. All right, so as you can see, the bar chart has has no intervals, no being we, because we're just talking about the categories, and we don't have to worry about intervals for from where to where, like a numerical one. So then we don't have like we don't have to have the two consecutive bar, and that's the reason why we don't have, we can have like a gap between each bar there. And you see that's I draw over here, it was a gap, right? Yeah, right. So this is different between bar chart and histogram. Okay. So we move to the next slide. Okay. Okay, actually we have it here. Sorry, I thought that we don't have. But anyway, yeah. So like I told you, if we have class as the categories, for for student interest in UCLA start class, and we have someone like unknown first year, sophomore, junior, senior, graduate. So the frequency in the right hand side column and total is going to be 20 students, right? And that's and you see that we have paragraph as in the right hand side here. Keep in mind that this histogram is for relative frequencies. Relative frequencies histogram. So it's using as relative frequencies will be, say, relative frequency will be equal to frequency and then divided by sample size. So for example, in here I have unknown will be relative frequency going to be equal to 7/20, because we have 7 frequency and divide by totals was 20. So that's the reason why I have unknown in there was what is this, 0.35. So 0.35, okay. So and so on, okay. And we can have the rest of them and then put us as a relative frequency in here. Okay, so so that's for the bar chart. Let me move to the next one. We compare between bar chart and histogram. So as I stated before, for the histogram, the bar might touch, right? It have touch for the consecutive intervals, and the bar width correspond to the beam width, okay? And the horizontal labels must be numerical orders, okay? So for the bar chart, we do not touch between each bar and can be designed with all the same, and no inherent order. So we don't have to put like from 10 to 20, like, and then 20 to 30, like in histogram bar chart, because bar chart is categorical, so will be just black, white, yellow, something like that, right? Keep in mind that there is like a spectral bar chart that we call like a Pareto chart. That is a bar chart that have been arranged from tallest to the shortest. So so this cannot be necessarily be done in a histogram, okay? So let's move to the next slide. In this slide, we talk about pie chart, and pie chart is a circle, right? A circle, and it divides into pieces. The area of each piece is proportional to relative frequency or percent of the data in the pieces. So it could be proportional to the relative frequency or percent of the data in those pieces. All right, so let's take a look at the example of the pie chart. So here in this pie chart, and you see that for the this is actually for the student who interested in ECOA start class, and we, like I say, we have like frequency for unknown one is 7, right? Is about 35%. It is in relative frequencies, and I mean usually for for the way to use pie chart, we should use like a relative frequency better. So I would suggest that we're gonna have like another table, I mean another column here for the relative frequency, which is f over n, and then you're gonna have like all of them is in here. Or you can do like convert it into percentage to make it easy to see how many percent for each pieces from a measure in here, right? Senior, as you see in here, it's about like 5 people out of 20. So it's look like it's having 1/4 of the whole graph, a quarter of the whole circle here, right? That's the reason why we have is like a 25% of the circle, right? Junior is for 20, right? This is 1/5, something like that. And then what else? Sophomore is 3/20, right? Unknown is 7/20. And graduate could be just 1/20. So this is just very list. So this is the way we don't draw the pie chart, right? In the StatCrunch, we can also draw pie charts easily. I have a I will have a video for StatCrunch drawing a pie chart with our discussion assignments. So please take a look at that and see how to handle that. All right. For the TI-83, let me check. I think they don't have that option, but let's check. Maybe I never used that before in the calculators. Yeah, so as you see, there's no option for the pie chart in here. Let me see the part 2. Yeah, it's like we don't have pie chart at all. So yes, so that's the reason why we don't have pie chart for the TI-83 or 80. I'm not sure 84 if we have yet, but 83 we don't. Okay. So this is for 2.3, and because it's kind of short, so I'm gonna just using this video and then move to 2.4. Okay. All right, so this is 2.4. All right. Okay, so clean this up. All right, so we keep working with picturing graph and picturing variation with the graph. So and we right now still working on categorical distribution. we wanna focus on mode and variability in categorical distribution. We also want to describing categorical distribution. Okay, so let's move to the next slide. All right. All right, so for describing a categorical distribution, let's recall that to describe a numerical distribution that's in 2.1, 2.2, we have state that we need to record the shape. Where is it? For the numerical distribution, we need to record the shape, center, and the spread, right? So since categorical has no inherent inherent order, so these measures do not make sense for categorical data. And then we have two main components of categorical data distribution. That the first one will be mode, which is typicals or the most frequency outcome of the categorical data. And the second one going to be variability or the diversity in outcome. Okay, so let's focus more on that for the mode of categorical data. Okay, so yeah. So the mode okay, in the categorical, so in the category that occur the most frequency. So the mode is, is the most frequency categories that appear for you. So let's say the difference in the mode for categorical and numerical data is what? Numerical data will be the mount do not need to be the same height. As you see in 2.2, in the numerical data, we have more as some mounts that it do not need to be same height. This is an argument with some different text and from some professor. So in this text, we consider that each mount in numerical data is going to be a mode. But some other, they don't. They just consider the mode is always the most frequency, the order data, even numerical or categorical. Okay, so but again, we are in this text, so then we're gonna just consider numerical data as gonna be the mouse, the mode of it's gonna be the mouse. So and it do not need to be the same height. For the categorical data, the mode must be roughly same height. Okay, so so we use the same wording as before in is unimodals. We have only one mode. We have bimodals. We have two modes with the same or very close frequency. And lastly is multimodals with more than two modes. Okay, so that is for the mode in categorical data. Now let's take a look at the some example mode in here. Okay, so so this is a bar chart, right? Not histogram, okay? Because this we have like categorical data in here. Someone don't know, someone lower, middle, and upper, right? So this is all about the survey for the new rule of 2580 American economic class they identify with. Okay, so this is about economic class. And the mode is the middle class. Okay, so as you see, the mode right now is a highest frequency, right? It's about like 50, I think. Okay, so highest frequency. Okay. All right. So is more in characteristic. After that, yeah, okay. All right. So that is it for this slide. Let's move on to slide number 6. I want to talk about variability of the category coded as. Oops, sorry. All right. Okay, so variability. Think of this is this diversities in the values. All right. What to look for in this first high variation we mean x value is represented with about the same frequencies, right? So represented with about the same frequency. So many observation in many different categories. Many different categories. What else? For the low variance, a small number of values appear a large number of times. So we're gonna have like many observations fall into a few categories. So let's state one more thing. Let's say that for the high variations, we distributions has loss of diversity, right? Okay, so for the low variations could be just like distribution have little diversity. Okay. All right, so okay, so cushion variability here is more about occurrence of many different values rather than frequency, many frequency. Okay, so keep in mind that variability is like more occurring many different values. Like if I talk about the um, the national release of people. This could be a lot of a lot of kind of national release, right? That's make high variety. Then instead of talking about national release, I'm talking about gender, just female and male, or I mean, if I talk about like marriage status, marriage status, right? It's gonna be the single marriage, without divorce, separate only. So that is not that much, not that high variability as the case talking about national release, right? Okay, so that is an examples about it, but let's see the examples of variability in this section that as you see in the left hand side here we have ethnic origin. This is gonna be, I would say, high variability, and the right hand side will be low variability, right? Because you can see that we have a lot of categories for the first graph, bar graph, right? And for second bar graph, we have everyone focused in one. Even though, I mean, in here we have just the same categories, but it have just everything try to get into only Hispanic. Right? So so that is about variabilities of the categorical distribution. Okay, so we finished 2.3 and 2.4. I'm gonna stop. Let me see if I can. Okay, so I'm gonna stop this section 2.4 here, and I'm gonna keep continue for 2.5 because this section 2.5 gonna be very quick. With only 3 slides, no, 2 slides actually. So 2.5 is just interpreting the graph. So keep in mind that for interpreting the graph, let me delete this. Okay, we need to have making appropriate graph and misleading graph, right? So we need to interpret to this thing, right? So we move to last slide number 3 here. And then for an appropriate graph, we call that the type of data you are dealing with determine the type of graph used. Okay, so for the numerical data, you should use dot plot, histogram, or stem plot to handle that. And also it depends on how many number of data values do we have, and are you having technologies in your hand? So so you're gonna decide which one you should go with. Keep in mind that histogram is very common for numerical data, and I mean you can use for the least data or for a lot of data, that's fine. For dot plot, just for the case that you have like not a lot of data, it's going to be a good idea to use that because the dot plot is going to be very detailed. For stem plots, going to be stem plot is the case that you don't have technology in your hand, and you should only should only for the case that have like not a lot of data. Okay. However, for the categorical data, you have only 2 choice. In this course, you have only 2 choice, which is only pie chart or bar chart, depending on which one you can use to show to visualize the data values. Yeah, both of them have each have a advantage and disadvantage of it. So choose the best one for you to describe the data to be the best. Okay. The last one for Okay. And the last one for appropriate measures. Keep in mind that the type of data is still you are dealing with to determine how you describe the distribution of data, right? So, and again, for the numerical data, you are using the shape, center, or spread. For the categorical data, you should just gonna use mode and variability to handle that. All right. Okay, so I'm gonna stop 2.5 here, and chapter 2 is finished. I'm gonna show you start going to graph histogram and pie chart on it. So please take a look at that and do the discussion chapter 2 together, and see you guys in chapter 3.